Current control voltage source, there's only one voltage source that we are discussing, and a current control voltage source means that the output voltage is controlled by the input current. And again, you can see that it's pretty much the same circuit as the inverting amplifier, right? We are not showing any input resistance. And there could be an input resistance, but we are not showing that. So when we do the analysis of this, extremely simple analysis, whatever current is coming here, I input, that current of course is gonna go here, and V output, and I input is equal to IF, of course. I input equals IF, right? So basically the current that is flowing here is I input. And when you apply Ohm's law over here, then 0 minus V out over R equals I input. And from that, you can write down that V naught is equal to negative I input times R, which is right here. So the output voltage depends upon the input current and the value of the feedback resistor, right? It does not depend on anything else. Here R is called trans resistance instead of transconductance. It's called trans resistance, and its value of course is in ohms. So if you're connecting any resistor between the output node and ground, then the output voltage will not depend on the value of the resistor. Output voltage will only depend on the value of the input current and the feedback resistor value. Let's look at the controlled current source. So the output current is controlled by the input current. This is the circuit right here, and in this circuit, as you can see, you have R1 over here, RL or RF, RL over here, sorry, not RF, RL over here. So RL is connected in the feedback loop, and R2 over here. Non-inverting input is grounded, so this is going to be virtual ground, 0 volt here. Input current is coming at the non-inverting input. This is the input current. Since no current goes inside the terminal, this input current is going to go through R2 to node A. So I'm assuming that we have node A over here. Okay, so we apply KCL at node A. Now observe that the voltage, we are calling the voltage across R2 V2. When I1 is going to flow through R2, a voltage will drop, of course, and we are calling this voltage V2. Now observe that this end is grounded or virtual ground, right? Yeah, virtual ground is here. So this end has virtual ground. This is node A, and likewise this is grounded and node A. So resistor R1 and resistor R2 will appear to each other as parallel to each other because both are connected between node A and ground. One is connected between the actual ground, one is at virtual ground. So they will appear parallel to each other. So whatever voltage you have here, the same voltage is going to appear over here, right, between the ground and node A, right? So when we apply KCL at node A, you have I1 going through towards node A, and I input going towards node A, and I1 going towards node A, and IL is going away from node A. So IL is equal to I input plus I1, and I input plus V2 over R1. Of course, I1 over here is what? V2 over R1. And when we combine these two, V2 is, of course, I input times R2. I inputs times R2 is also V2. So we change this V2 into I input times R2, and I input is common, we take it out. So it's going to become load current equals I input times 1 plus R2 over R1. And we call 1 plus R2 over R1 as the current amplification factor beta. Like you remember in BJT, the collector current depends on the base current. So that's the amplification factor beta. So the load current depends upon the input current multiplied by the current amplification factor beta. So that's your current controlled current source. You can determine the dynamic range of the load current, but since the load current depends on the input current, first we determine the dynamic range of the input current, and then from that we can determine dynamic range of the load current. And you can look at the derivation over here. It's pretty straightforward derivation. Few examples. from the sources. So this is a current controlled current source example. Again, go over it. This is the current controlled current source, so the example is related to that circuit. And that's the end of controlled sources.